Hello and welcome to Math on the Go. So in the previous video, I showed how to find the derivative using the definition of a derivative. In this video, we're going to talk about the power rule. So the power rule states if f of x equals x to the n, then f prime of x equals nx to the n minus 1. Now this can also be written as d over dx parentheses x to the n equals nx to the n minus 1. These two statements say the same thing. It's just two different ways of writing derivative of a function. And also, before we get started with any examples, let's look at doing the derivative of a constant. So if f of x equals c, where c is a constant, then f prime of x equals 0. So what this is saying is if you have a function which is just a number, say the number 3, then if you take the derivative of the number 3, you're going to get 0. So the derivative of a number is 0. So with this little bit of information, let's look at our first example. F of x equals x squared minus 2x plus 1. So the derivative, remember our rule, we have n comes out front, so we have 2x, and then we have our n minus 1. 2 minus 1 is just 1. So we have 2x minus, again, we have a 1 here. Bring that out front, multiply it by the 2, which is just 2. And then subtract that 1, which gives us 0. So anything to the power of 0 is just 1, so that leaves us with just 2 here. So our final answer, f prime of x, we can factor a 2 out, which gives us 2 times x minus 1. And that's our first derivative using the power rule. Let's move on to another quick example. We have, say, f of x equals 12x cubed plus 14x squared minus 2x plus 1. All right, so we have f prime of x. This is where we start doing our derivative. So we have 12 times 3 x 3 minus 1 plus 14 times 2 x 2 minus 1 minus 2. Remember, x with no exponent has a 1. So 2 times 1, x 1 minus 1, plus, remember just up here, the derivative of a constant is 0. 1 is a constant, so that equals 0. All right, now let's just clean this up and finish it off. We have f prime of x equals 36x, 3 minus 1 is 2, so 36x squared plus 28x, 2 minus 1 is 1, so we'll just leave that exponent empty because that just means there's 1 up there. minus 2 times 1 is 2. And again, we have x to the power of 1 minus 1, which gives us 0. Anything to the power of 0 is 1, so again, we're just left with a 2. So our final derivative is 36x squared plus 28x minus 2. All right, let's move on to the next example. But before we start that example, we're going to look at another rule. Say you have c f of x. That is going to equal c f prime of x. What this says is that we can factor out a multiplicative constant from a derivative if we need to. So I'll show you an example of that. Let's say we have f of x equals the square root of 3x. All right, let's break this down a little bit more. We have f of x equals the square root of 3 times the square root of x. Now let's bring this out a little bit more. F of x, we have the square root of 3 times the square root of x. So we factored out this multiplicative constant. So, and then just because we're working with square roots here, we're not going to do anything with this square root, but we are going to change the square root of x to x to the 1/2. Makes doing derivatives a lot easier. So now let's work on our derivative. F prime of x equals the square root of 3 times, again, we're going to pull our 1/2 out in front. Gives us x. And then we have 1/2 minus 1. So from here, we have f prime of x equals the square root of 3 times 1/2 x to the negative 1/2. Well, just to clean this up a little bit more, we have f prime of x equals the square root of 3 over 2. And then when you have a negative exponent attached to your variable, to get that to be a positive, we move it down to the denominator. So we have x to the 1/2. And then just to finish this up, we have the square root of 3 over 2 times the square root of x. And that's our derivative. Let's have a look at one more derivative for this video. Let's say we have f of x equals 4x cubed minus 1 over 3x to the 5th plus x minus 23. Before we can do anything, when you do a derivative and you have an exponent or a variable with an exponent in the denominator, we need to move that up to the numerator. It's the only way we can work with derivatives here, using the power rule. So let's rewrite this. 4x cubed minus x to the negative 5th over 3 plus x minus 23. Okay, now we can get into doing the derivative now. So we have f prime of x equals 4 times 3 x to the 3 minus 1 minus negative 5 x to the negative 5 minus 1 over 3 plus, we're going to bring down this 1, x 1 minus 1 minus, well, 23 is a constant, so that's just 0. All right, so now we just need to mess around with all the stuff that's in red here. F prime of x equals 4 times 3 is 12. X, 3 minus 1 is 2, so 12x squared. We have a -5 and a negative sign, so this is going to be positive. 5 x to the -6 over 3 plus, well, we have 1 times x to the power of 1 minus 1, so that's 0. X to the power of 0 is 1. 1 times 1 is 1. All right, so we're almost done here. We have this negative sign, and to clean this up, we're going to bring x back down to the denominator. So we have f prime of x equals 12x squared plus 5 over 3x to the 6th plus 1. And that's how you do the derivative using the power rule. So thank you very much for watching. Please like and subscribe, donate a coffee through the link in the description if you enjoyed this video and want to see me do more. And I'll see you next time.